Good morning. Welcome to CEI. This is Dr. Sekhar Chandra. Today I'll teach chemistry and the topic is water. Now, water mainly I'll teach today the properties of water, physical as well as chemical properties. Now, physical properties all of you know. Every day you are watching or you are taking water, drinking water, bathing water, etc. You know water is a colorless, odorless, tasteless. It's a definite boiling point, definite melting point, etc. But the important is chemical properties of water. Today I'll teach chemical properties of water. Now first, reaction with metals. Reaction with metals. Now, reaction with metals. Water at room temperature. Water at room temperature. Alkali metals and alkaline earth metal like calcium, they react with water at room temperature to form respective alkalis and hydrogen gases evolve. Like sodium, potassium, lithium and alkaline earth metal calcium, they all react with water kept at room temperature, evolving hydrogen gas. Now, twice Na plus H2O Similarly, twice K plus 2 water, twice KOH plus hydrogen, alkaline earth, CaOH whole twice plus hydrogen gas. Now, you see the respective alkalis, NOH, KOH and calcium hydroxide. The interesting point that when sodium is dropped to water, then sodium catches fire producing golden yellow flame. Similarly, potassium, when it is dropped in water, it produces violet flame. That means it catches fire immediately and violet flame is observed. Similarly, calcium, they react to form alkali calcium hydroxide and hydrogen. Now, this is the reaction between alkali metals and water at room temperature. Now, water, when it is boiling condition, there are few metals are there which can react with the boiling water. They are like examples are lead, magnesium, zinc, etc. Lead, magnesium, zinc, etc. They react with boiling water to evolve hydrogen gas and respective oxide or hydroxide. Like magnesium, water, they form magnesium oxide or hydroxide and hydrogen gas. Aluminium, aluminium hydroxide, hydrogen gas. Lead hydroxide, hydrogen gas, etc. Now examples: water. Number 2, with boiling water. With boiling water. Now boiling water, there are few metals are there like Tb, zinc, magnesium, aluminium, etc. They react with boiling water to form oxide or hydroxide and hydrogen gas is evolved. Similarly, zinc oxide plus hydrogen gas is evolved. Magnesium oxide plus hydrogen gas is evolved. Aluminium plus water, Al2O3, or aluminum hydroxide plus hydrogen gas. So there are few metals which can react with the boiling water to form their oxide or hydroxide, and hydrogen gas is evolved. Number 3, with steam. Now, when steam is passed over red hot iron, then hydrogen gas is evolved with the formation of ferrosulfuric oxide or mixed oxide. Now, this is the method from which we can prepare hydrogen gas in the industrially. On the large scale preparation, we can use this method, and this is known as Lenz process, LANES, Lenz process, by which we can manufacture hydrogen gas. How? When steam is passed, just I told, when steam is passed over red hot iron, then iron becomes oxidized to ferrosulfuric oxide, Fe3O4, and hydrogen gas is evolved. This is the manufacturing method of hydrogen gas known as Lenz process. Fe plus 4H2O, Fe3O4 plus 4 hydrogen gas, 4 hydrogen molecule. This method is called Lenz process. It is the method for the manufacture of hydrogen gas. That means industrial preparation of hydrogen gas. For the large scale preparation, we can apply this method. Next, reaction with acidic oxide. Acidic oxide. What do you mean acidic oxide? Non-metallic oxides are called acidic oxide, like carbon dioxide, sulfur dioxide, sulfur dioxide, phosphorus pentoxide, etc. They are called acidic oxide. Why? Because they dissolve in water or they react with water to form the respective acids. That's why they are called acidic oxide. Now, this acidic oxide, they react with water to form the respective acids. Like carbon dioxide, acidic oxide, non-metal oxide, react with water to form carbonic acid. Sulfur dioxide plus water, they form sulfurous acid. Similarly, sulfur trioxide react with water, they form sulfuric acid. Phosphorus trioxide, they react with water to form phosphorus acid. Similarly, P2O5, phosphorus pentoxide, they dissolve in water to form phosphoric acid. Nitrogen pentoxide, they form nitric acid. Nitrogen trioxide, they form nitrous acid. In this way, all the non-metal oxides, which are called acidic oxide, they form respective acids. What important examples I am writing here? That is nitrogen dioxide. Another acidic oxide, they react with water to form nitrous acid plus nitric acid. Now, nitrogen dioxide, it reacts with water to form a mixture of two acids, which is a mixture of two acids. They are nitrous acid and nitric acid. That's why NO2 is known as mixed anhydride. NO2 is called mixed anhydride because it dissolves in water to form a mixture of two acids, that is nitrous acid and nitric acid. Next, reaction with non-metal oxides. Reaction with non-metal oxide means basic oxide. Reaction with basic oxide. Basic oxide, who are the basic oxide? Basic oxides are metallic oxides like sodium oxide, potassium oxide, calcium oxide, magnesium oxide, etc. Zinc oxide, copper hydroxide, they are called basic oxide. Now, basic oxides, they react with water to form alkali. And like Na2O plus water, they form sodium hydroxide. Similarly, K2O plus water, they form KOH, alkali. And calcium oxide plus water, they form calcium hydroxide. So, metal oxides, which are called basic oxide, some basic oxides, they dissolve in water to form respective alkalis. So one conclusion we can draw from this reaction that bases are metal oxides or hydroxides. Bases are metal oxides and hydroxides, and only soluble oxides and hydroxides are called alkalis. Example: sodium oxide, potassium oxide. They are called alkali because they dissolve in water to form the respective alkalis. So we can conclude all alkalis are bases, but all bases are not alkalis because there are many oxides are there which are insoluble in water, like cupric oxide, like ferric oxide, ferrous oxide. They are insoluble in water. They are bases, but they are not alkalis. But sodium oxide, potassium oxide, calcium oxide, magnesium oxide, medium oxide, they are soluble in water, so they are base as well as alkali because they dissolve in water. Okay. Next, reaction with non-metal. Reaction with non-metals. Now carbon plus now when steam is passed over white hot coke, then we get a mixture of two gases known as water gas, which is nothing but a mixture of carbon monoxide and hydrogen. This is called water gas. When this is steam, when steam is passed over red hot iron or white hot coke, then we get a mixture of two gases known as water gas, which is a mixture of carbon monoxide and hydrogen. Similarly, chlorine react with water, that means chlorine gas will pass through water. We get a mixture of two acids, HOCl plus HCl. HOCl, hydrochloric acid, which is very unstable to form HCl plus nascent oxygen, and nascent oxygen being unstable to form oxygen gas. So, when chlorine gas is passed through water, we get hydrochloric acid and oxygen gas is bubbled through. Oxygen gas will be evolved. Why oxygen gas will be evolved? Because after passing through water, we get the chlorine water, which is a mixture of HOCl and HCl, hypochlorous acid and hydrochloric acid. Hypochlorous acid being unstable, it dissociates or decomposes to hydrochloric acid and nascent oxygen. And nascent oxygen being very unstable, very unstable, two nascent oxygen combine together to form an oxygen molecule and evolve as oxygen gas. Okay. Number 8, reaction with carbide. Reaction with carbide. Carbide, few examples I'll give you here. Carbide means aluminium carbide, Al4, C3, calcium carbide, CaC2, magnesium carbide, Mg2C3, boron carbide, chicken. There are 3 examples I am taking here: aluminium carbide, calcium carbide and magnesium carbide. They react with water to form aluminium hydroxide plus methane gas. Here calcium hydroxide plus C2H2 ethyl gas, magnesium carbide plus water, they form magnesium hydroxide plus propine C3H4 propine. That means propine formula হচ্ছে this is called propine. This is ethine. This is methane. So on hydrolysis or by reacting with water, it forms methane gas, calcium carbide, they form ethine gas, magnesium carbide, they form propine gas, PROPYNE, propine gas. So on hydrolysis of the carbides, they form, not the balance, you have to balance these reactions. Here it will be 12 water, so it will be 4 aluminium hydroxide plus 3CH4. In this way, you have to balance other reactions. So on hydrolysis of carbide, we get alkane, alkyne, and alkyne. Both are alkyne. On hydrolysis, we get the different organic hydrocarbon. Next, number 9, reaction with peroxide, metal peroxide, sodium peroxide or potassium peroxide, sodium peroxide or potassium peroxide. Now Na2O2 plus water, we get sodium hydroxide plus hydrogen peroxide. K2O2 plus water, we get twice KOH plus hydrogen peroxide. So peroxide on hydrolysis, we get the hydrogen peroxide. And the last reaction, today's last reaction, that will be reaction with metal hydride. Metal hydride. Metal hydride. Metal hydride, like sodium hydride, potassium hydride, calcium hydride, they react with water to form alkali plus hydrogen gas. Plus hydrogen gas. Twice plus 2H2O, we get sodium hydroxide plus water, we get sodium hydride plus water, we get sodium hydroxide plus hydrogen, potassium hydride plus water, potassium hydroxide plus hydrogen, calcium hydride plus water, we get the calcium hydroxide plus hydrogen. So with hydrides, we are getting hydrogen. With peroxide, we get oxygen. With carbide, we get the hydrocarbon, gaseous hydrocarbon. So today, no more chemical properties of water. We have finished. Next class, we'll discuss about the other related important questions in the with respect to chemical properties. I'll teach. So today is no more. Thank you so much. If you like this video, please do like, subscribe and share. Thank you.